Welcome to Ask and Learn.
We're given an initial value problem. We are asked to use Euler's method with a certain step size to find an approximation of a value of the solution at some x. So, in part A, we have the differential equation y prime equals cosine of x plus y with initial value y of 0 equals 0, and we want to find an approximation for y of 0.6. In part A, we use step size h equals 0.2. From our initial value, we have that x0 is equal to 0, and y0 is y of x0, which is equal to 0 as well. x1, this is x0 plus our step size, so this is 0.2. y1 is equal to y0, which is 0, plus our step size, times the function cosine of x plus y evaluated at x0, y0, which is simply cosine of 0, which is 1. So this is equal to 0.2. x2 is equal to x1 plus our step size, 0.4. And y2 is equal to y1 plus our step size times our function cosine of x plus y evaluated at 0.2, 0.2. This is cosine of 0.4. Although we could just keep it in this form, I'm going to approximate this. So this is about equal to 0.384. Two, 1, 2, 2. x3, this is going to be x2 plus our step size, which is equal to 0.6. And we have that y of 0.6 is approximately equal to y sub 3, which is equal to y sub 2, which I'm just going to write as y sub 2, plus our step size, 0.2, times our function evaluated at 0.4 y2. So this is cosine of 0.4 plus y2. And this is about equal to 0.525811. If you use the store function, you might get a more accurate value, but this is fairly accurate. Now in part B, we're asked to use a different step size, this time a step size of 0.1. So now we expect to have 6 steps instead of 3. Again, we have that x0 is equal to 0. And y0 is equal to 0. So x1 is x0 plus our step size, which is 0.1, and y1 is equal to y0, which is 0, plus our step size, times our function evaluated at x0 and y0, which is simply cosine of 0, which is equal to 1, so this is 0.1. x2 is equal to 0.2, excuse me, and y2 is equal to y1 plus step size times our function evaluated at x1 plus y1. This is going to be 0.2. And again, we could just leave this in this form, but for simplicity, this is approximately equal to 0.1980067. Our third step, x3, is 0.3. And y3 is equal to y2 plus our step size times our function evaluated at y2 at x2 y2. So this is going to be 0.2 plus y2. This is approximately 0.29019002. Step 4, we have x4 is equal to 0.4 and y4 is equal to y3 plus our step size 0.1 times our function evaluated at x3 and y3. So cosine of 0.3 plus y3, which is equal to approximately 0.37323737. Step x5 is equal to 0.5. One more step after this one. And y5 is equal to y4 plus our step size times our function evaluated at x4, y4. So this is 0.4 plus y4. So this is y5 equals y4 plus our step size times cosine of 0.4 plus y4, which is approximately equal to 0.444835. And finally, step 6, we have x6 is equal to 0.6, and we have that y of 0.6 is approximately equal to y6, which is equal to y5 plus our step size times function evaluated at x5, y5, so 0.5 plus y5, and this is approximately equal to .503424. So we see that these answers, out to the first digit at least, are the same. We would expect that our second answer is going to be closer to the true value than our first answer.